Hello everyone, assalamu alaikum. So welcome to today's video. So we are going to start our chemical calculation series today, and we are going to start with part 1, which is calculating molecular mass. So first of all, let's see what we must know to understand today's lesson. Number one thing we need today is atomic mass. So you already know about atomic mass, so let's make a short recap on this one. So atomic mass is actually the sum of number of protons and neutrons in an atom, right? But for isotopes, this thing is different, right? So we can talk about it in another video, not today. So basically we are going to depend on atomic mass. And what is atomic mass? Generally atomic mass is the number of addition of number of protons and neutrons in an atom, and there will be a periodic table given on your question paper. So in your periodic table, the atoms are arranged depending on their atomic number. That means how many protons they have. So in your periodic table, each of the atoms are written like this. You have the symbol, then you have a number written on top, then you have a number written on the bottom. The number written on top is the atomic mass. This is the atomic mass. And the number written at the bottom is atomic number. So to calculate molecular mass, we'll be needing the number at the top. That means the atomic mass. So just going to the periodic table, you can literally find out the atomic mass of any atoms in your periodic table. So how can we use that information to calculate our molecular mass? Let's talk about a molecule. Let's say oxygen. We have oxygen. So this is an oxygen molecule, and in this oxygen molecule we have two oxygen atoms, remember. So go to your periodic table and you will see that number written on oxygen is 16 and number at the bottom of oxygen is 8. So we are going to use the top one, so 16. Now 16 is the mass of one single atom. How many atoms we have here? We have two atoms. So this is the mass of one atom and this is the number of atoms. When you multiply it, we're going to get a value. So this one actually represents the whole mass of this molecule. So this is our molecular mass. Let's see another example. So our second example is carbon dioxide. Now we have two different atoms here. One is carbon and one is oxygen, but we have two oxygens here. Okay, if you go to your periodic table, you will see the number written on top of carbon is 12 and oxygen is, we have already seen it, is 16. So when you calculate it, we have one carbon atom, the mass of that atom is 12, then plus, because we don't have any more carbon, so we are going to add them to the next one. Now we have oxygen. The mass of oxygen atom is 16, but we have two oxygen atoms, so we have to multiply with the number of atom. Now calculate it. You have 12 plus 32, which gives you 44. Now this 44 is the molecular mass of carbon dioxide. Now let's do some bigger molecules and see how we can calculate the molecular mass of those molecules. Stop. Wait. This one. Okay. So this is our next molecule. We have sulfuric acid with us, H2SO4. Go to your periodic table, you can see these values. One on top of hydrogen, so we need the number top of the atom. And if you go to sulfur, you will see 32. If you go to oxygen, you will see 16. So these are the atomic mass of hydrogen, sulfur and oxygen respectively. Okay, now how can you calculate it? See, we have two hydrogen atoms. First of all, the mass of hydrogen atom and then multiplied by number of atoms. Okay, hydrogen is done, then add it. So now we have sulfur. Mass of one sulfur atom is 32 and number of sulfur atom is 1. You can multiply by 1, but you can also skip it, it doesn't matter. Then we are done with sulfur. Let's move on to oxygen. Now we have 4 oxygen atoms. Mass of one oxygen atom is 16. We have 4 oxygen atoms, so we have to multiply with 4. Now if you just calculate all of them, you have 2 plus 32 plus 64, which in turn will give you 98. So we can say that at the molecular mass of sulfuric acid is 98 gram. Let's see another one. Let's say we have another one called, let's say we are going to do glucose, C12, C6, H12 and O6. Again, we know that the number written on carbon is 12 number written on hydrogen is 1, number written on oxygen is 6. So let's see how we can do that. We have 6 carbon atoms, but first of all, the atomic mass of carbon is 12. Number of carbon atoms here is 6. We're going to multiply it with 6. Then we are done with carbon. Let's move on to hydrogen. Now we have 12 hydrogen atoms. Mass of one hydrogen atom is 1, and we will multiply with number of atoms present here, which is 12. Then we are done with hydrogen. Let's move on to oxygen. Mass of one oxygen atom is 16, and we will multiply with number of oxygen atoms, which is 6. So in total we can see that we have 72 plus 12, and we have 96. So if you can add them, when we add them, you are going to get 180. So the molecular mass of glucose is 180. Now we have seen smaller molecules and bigger molecules. I think you can actually calculate the molecular mass of any molecules now. Now this will be very handy when we are going to our next part, which is mole calculation. We are going to see the idea of mole, and we will know how mole is related to this molecular mass, which we will call later molar mass. So that's it for today. Just go through these examples and practice with different molecules. I think you'll be very fine for the next one. Okay, we'll be coming back very soon with our part 2. Stay tuned with us. Thanks. Thank you.